Algebra 2, Lesson 4.4a, Factoring Sum and Difference of Cubes and Polynomials with 4 Terms. So recall earlier we learned how to factor difference of squares. For example, 4x squared minus 9. So this was considered a difference of squares because we can make this binomial fit this pattern right here, right? Where we had perfect squares, right? So 2x squared gives us 4x squared, and 3 squared gives us 9. And there was a minus sign in the middle. So our factors were 2x plus 3, 2x minus 3. So this is kind of like a special pattern to factor a difference of squares, which is a special type of binomial, right? So now we also have difference of cubes, but also sum of cubes, okay? So these have special patterns as well, okay? So basically, if you can get the problem, right, to look like a to the third plus b to the third, this would be considered a sum of cubes. And this would be the pattern, okay, that you follow, okay, to factor it. The same way with the difference of cubes, if you can get a to the third minus b to the third, right, then this would be the special pattern we use to factor the difference of cubes, okay? Now, one thing that I'll mention is I call these SOAP problems, okay? So you kind of remember the word SOAP, right? And I'll explain what these letters mean. The word SOAP kind of helps you remember the signs for these parentheses, okay? So you notice this first sign here is the same as, right, the a to the third plus b to the third, right? So our answer here, the first sign is the same. This middle sign here is opposite, right? That's why it's O, right? And then the last sign is always positive, AP, always positive. All right, so that's what the SOAP or SOAP stands for. Same, opposite, always positive. So same, opposite, always positive. Okay, and you notice it's the same, right, for a difference of cubes as well, right? So we've got the same, we've got opposite, always positive. Okay, so if you just remember the word SOAP, it helps you remember what the signs should be. Okay, so let me show you how to do this first example here. So let's say we need to factor this. Okay, so first of all, anytime you're factoring, we look for a GCF. This one doesn't have a GCF, right? But if there was, we would take it out. Second, you should recognize that, hey, this is a perfect cube. I can make this problem, all right, 64x to the third, that's 4x to the third. All right, 1 is 1 to the third. So I can make this problem fit this pattern right here. So that means that it is a sum of cubes, okay? So to factor this, here's the special pattern. So you're always going to have two parentheses. The first one will be a binomial. The second will be a trinomial. And then we want to put in the signs. So we have the same, opposite, always positive. Now whatever these are right here, they're just going to go in the binomial. This first term of the trinomial, we just square, right, the 4x, so we get 16x squared. To get the middle term here, we multiply these two, so that's going to be 4x. Now you don't need to worry about the sign because it's already there. Okay, so you just multiply whatever these are. Okay, and then over here we have the 1, we square it and we get 1, and that would be your answer. Okay, let me do this one here so I can make this problem. All right, fit this format. 27x to the third is 3x to the third. 8 is 2 to the third. So if I factor this, I'm going to have two factors. One's a binomial, one's a trinomial. So the signs, we have the same, opposite, always positive. So the 3x and 2, all right, go in the binomial spot. To get this first part of our answer for the trinomial, we square the 3x, so that's 9x squared. To get the middle part, we multiply these two. Right? When you're multiplying, you can ignore the signs, right? So it doesn't, don't think it's a negative 2, okay? Just multiply these two, 3x times 2, it gives you what? 6x, okay? So when you're multiplying to get this middle term right here, you can ignore the signs, because remember when we use SOAP, we put in the signs already, okay? And then the last part, we have 2 squared, so that gives us 4. Okay, so that's all that is right there. So let's take a look at some more examples. Alright, so we need to factor these two problems. So first of all, look for a GCF. There's no GCF. And then I need to recognize that, hey, this looks like it's going to be a difference of cubes, because I can make this problem fit this format, right? So when I factor this, I'm going to have a binomial, have a trinomial, set up the signs, same, opposite, always positive, okay? And then the x and the 5, we're going to go here and here. I square the x, that's x squared. I multiply the x times the 5. Remember, when we're multiplying, ignore the signs, right? Because we already have the signs in here. So x times 5, right? So don't think of it as a negative 5. It's just x times 5. It's 5x. Then 5 squared is 25. Okay? Same thing over here. I look for a GCF. Oh, there's no GCF. So you need to recognize that I can make the problem fit this format. So that's will be 2x. That'll be 3. So I've got my binomial, got my trinomial. Let's put in the signs. Same, opposite, always positive. 2x and the 3. I square the 2x, 4x squared, right? 4x squared. Multiply the 2x and 3, that's 6x. 3 squared is 9. Okay? And that's your answer. Alright, let's factor these problems here. So first of all, notice number 3 has a GCF, so I have to take that out. So I have the 2 out here. So then that's going to give us x to the 3rd minus 64. Then I recognize x to the 3rd here. I can get it to fit our difference of cubes format. So this would be x, and that'll be 4. So when I factor this, I have my binomial, I have my trinomial. Let's put in the sign, same, opposite, always positive. And the x and the 4, I square the x, that's x squared. Multiply x times 4, that's 4x. Square the 4, 16. And then don't forget your GCF, it needs to be a part of your answer. X squared, okay? So I end up with 8x to the 3rd minus 27, okay? Now, it looks like I can get this to fit the format of a difference of cubes. So then I have 2x here and 3. So my binomial and my trinomial, let's put in the signs, same, opposite, always positive. So I'll have 2x and 3 here, square the 2x, 4x squared, multiply the 2x and the 3, 6x, 3 squared is 9, don't forget my GCF, 2x squared. That would be your, alright, final answer there, completely factored out. Now let's talk about how to factor a polynomial that has 4 terms, okay? So whenever you have something that has 4 terms, typically a polynomial, you want to try and factor it using what we call the grouping method, okay? So what I'm going to do is, the grouping method, what I'm going to do is I'm going to group the first 2 terms together, okay? So I'm going to group these together right here. And then I want to think, what's the GCF that I can take out from here? Right, so usually there's going to be a GCF, so I can take out an x squared. So then that will leave me with x plus 4, right? Then I'm going to group the next right, 2, and take out the GCF from here. So it looks like I can take out a positive 2, right? And then that'll leave me with x plus 4. Now when you're using the grouping method, right, these binomials should be the same after you take out the GCFs. If they're not the same, then you might have done something wrong, or maybe the problem cannot be factored using grouping. Okay, so this is a good indicator if you're doing the problem correctly, if these binomials are the same. Okay, so your final answer, all you're going to do is, well, you're going to take whatever your GCFs are, right, the terms that are on the outside, you're going to put them together in a binomial. So x squared plus 2, right, so we take these, we put them together in a binomial, and then the x plus 4, right, you only need to write it one time. Okay, you only need to write it one time. And the reason why is, if you take a look at this, if I FOIL this, right, I'm going to take the x squared and I'm going to multiply it to the x and the 4, the same way I'm doing over here, right? And then I take the 2, I multiply it to the x and the 4, the same way I'm doing it over here. That's why you only need to write the x plus 4 one time, even though there's 2 of them over here. Okay? So this would be your final answer. Okay, let's take a look at number 6 here. So whenever we're factoring, we always look for a GCF, right? So I see a GCF here. So the biggest number I can take out from all of these is going to be a 2. So if I take out a 2, I'm going to get 3x to the third plus 6x squared minus 4x minus 8. Right? And then I'm going to factor by grouping since I have 4 terms. So I'm going to group the first 2 terms together. So I'm grouping these together. So I'm going to take out the GCF, which I see is 3x squared. So that'll leave me with x plus 6. Oops, not 6. X plus 2. Over here, I can take out a GCF. Looks like I can take out a negative 4. Right? So I want to take out a negative because I need the x to be positive. Right? So then I'll get a positive x, then a positive 2. And like I said before, these binomials should be the same if you're doing it correctly and if you can factor the problem. Okay? So since they're the same, it's a good indicator that I'm doing the problem correctly. So my final answer, I have the 3x squared minus 4 as one factor, x plus 2 as another factor. And don't forget your GCF at the beginning. That needs to go in the front. And that's your final answer there. Okay? Alright, let's take a look at number 7 here. So let's look for a GCF. It doesn't look like there's a GCF. Okay? So I'm going to group the first 2 together, take out the GCF, which is x squared. So I'll get an x minus 6. Over here I can take out a positive 2 from the second group here. That'll leave me with an x, right, minus 3. Okay, now you notice these are not the same, right? And like I told you before, if these are not the same, well, it's either you're doing it incorrectly or you cannot factor this, right? So let's just double check to make sure we did everything correctly. So the GCF for the first group here, right, the first 2 terms, so I take out the x squared, so that looks correct. And that leaves me with x and a minus 6. So that looks correct so far. The second group, right, I take out the 2, that leaves me with x minus 3. Okay, so I've done everything correctly and these binomials are not the same. Okay, so if you did everything correctly and these binomials are not the same, right, that tells you that this problem here cannot be factored. Okay, so this cannot be factored. Can't be factored. Okay, so I gave you an example where to show you that not every single one of these problems can be factored. I mean, 99% of the time you will be able to factor them. But yes, it is possible to get a problem that cannot be factored. Okay. Number 8 here, let's look for our GCF. So it looks like I can take out an x, right? And then also I can take out a 3. So it looks like I can take out a 3x. Well, that would give me 2x to the third minus 3x squared minus 10x and then plus 15. And then I'm going to factor by grouping because I have 4 terms. So I'm going to group these together and take out the GCF, which is going to be, it looks like x squared. So I'm going to end up with 2x minus 3, right? Over here I can take out a negative 5. I'm going to end up with 2x, right, minus 3. Okay, so our binomials are the same, so that tells us we're doing it correctly. So I have x squared minus 5 as one factor, and 2x minus 3 as the other factor. And don't forget your GCF, 3x. That's your final answer there. Okay.